Hello everyone, I'm Frank, and this is today's video of Sudokuvania. Hopefully the last video of Sudokuvania. We are on the final room. And it's the throne room, I believe. And it's deconstruction. Let's just get straight to it. We have to locate 9 3x3 boxes to be placed in the 11x11 grid. And we need to place the digits from 1 to 9 into each box without repeating in a row or a column. Cells not in any region must remain empty. So yeah. Anything that has a 2x2 space around it. Sorry, anything that has. So I believe the same rules for outside the grid is the same for inside the grid. So the center digits must be filled. So this has to be part of a region. I think the indexes actually have to be filled. Is that right? I don't even know if that's right. This would be 3, 4, 5, 6, 7, 8, 9. And these would be 6. The digits in an arrow must add up to the sum in the middle here. So these are two separate ones. It could be two separate ones here. This, however, cannot be 5 digits adding up to 1. So this is definitely a digit. So we definitely have a digit here. We have a digit here. We have a digit in each of the center of the zipper lines. We have a at least one of these is valid. These have to be two separate regions here. Yes, I believe both of these are valid, and both of these are valid. Because you have to have a 2x2, to be in a 1-to-2 ratio. Actually, is that the case? I mean, technically you could have 0 and... Well, you can't have a 0. So, for it to be 2 by... I mean, you could have blank and blank, technically. But I believe in the outside the grid rules, we have... Well, is this technically outside the grid? I don't know. Yeah, black dots always border 2 digits. Blank lines or whisper lines are ignored. Okay, so there's that. Oops. Dang it. Okay. So we do have 2 digits on each of the sides of a black crop key dot. Whisper lines can have empty spots, so can thermometers, so can arrows, but arrows need to add up to the same digit. So this is at most 3 of the same digit, and it can be 2 or, well, it can't be 1, because you can't have repeats within the same row or column. So this is 3, so this is either, okay, hold up. That's not going to be good. Ugh. Okay, let's try to get that in again. I'm trying to zoom into the 11 by 11 area. Since we've done basically all but one of the hidden quests, but the problem is we don't know where that last hidden quest is. Let me go here. Oh, that's too much. Okay, this is 11 by 11 area. Where are the starts of these squares going to be? For this 11 by 11 area, you can have a start be here. That works. A start be here. And a start be here. That works. Any of these three works. Any of these three actually works too. So for every 9 by... Okay, so for every 3 by 3 area, you could have something like this, right? This is unlikely. These have to be different, so this is not allowed. You could have something like that. Okay, so let's not do that one yet. Actually, can you even have this one? You cannot have that one, right? If you tried to have this, the problem is this has to be a valid, this has to be in a valid 3 by 3 region. And that wouldn't work. So it cannot be this. It cannot be this, because then this would be in the same region. So this has to be, actually, what part region can this be part of is the question. It cannot be part of this one. It can't be part of actually any of these, right? So it can't be anything with these three as the upper left corner, because it would block that from having a 3 by 3 region. Actually, no. It cannot be here, and it cannot be here. But technically, it could be here, right? So, okay, so for this region, it cannot be here, because that blocks this from having a 3 by 3 area, being in a 3 by 3 area. Can't be here, because that blocks this from being in a 3 by 3 area. It could be something like this, or this. So let's mark the valid ones. We'll mark those in blue for this region. It could be here. It could be here. It could be any of these four, or it could be starting in the upper left corner here. So this would be valid. This would be valid. This would be valid. Sorry, this is not valid. These two are not valid, because they would basically say that these two are in the same region, but they can't be because they have to be the same digit. So these are not valid. These two are valid, and this one's valid. Now this region, it has to be either one of these five, right? It has to be either here, or here, or here. And I think all of those are valid. You have to have at least one on each side of the zippers to be valid. You could just have, you could have something like this. Oh, that's interesting though. If you have something like this, the problem is none of these could be valid then. Hmm. You have to see at least 3 skyscrapers, 3 cells this way. You have to see at least 3 cells this way, and at least 3 cells this way. Hmm. Interesting. Okay, so what can you not have for this cell? This doesn't work. Actually, that's fine. It could be here. That's valid. This is not valid because then that would force this to be here and then this wouldn't work. This is also not valid for the same reason, right? You can only have this and these two for that one. So this one could allows essentially this and then another region, which is possible. So these two are out. This one works. So this is valid. This is also valid. Because it can go that way and then go here. And this is valid. As long as it goes that way, right? Hold on. Is this valid? This is not this could potentially be valid. So these are all potentially valid. But if we have this, the problem is we need to have this be an area or this be an area. And that doesn't work because these two would then be blank. And these two would have to be the same as that. So this does not work, actually. If we tried to have here, we have a similar problem, right? Because you would try to have an area here. You would have to have an area here for this cell. But the problem is that these two would be blank. These would all be in the same region and would have to be the same digit. So that's not allowed. If we have here... So, okay, we have this region. The problem... Okay, so either... That could work, potentially. So again, you cannot have this region because that would force you to have this region for this area. So you cannot have this region here because that forces this to be the region, and we don't have a region for these two, which we know we have a region for. Similarly, here is a problem there for the same reason. This doesn't work because one of these two would have to be the start of the upper left corner of this region that contains this cell. And then these two would not have a region, so they would be blank. These would be in the same region, and they would not be this. They would be this have to be the same digit, which is not allowed. So if we had this one, well, one thing is, if you have this one, these cannot be blank, right? If they were both blank, these would have to be the exact same digit. So if we tried to have something like this, the problem is these would have to be the exact same digit in the same 3x3 box. So this doesn't work either, right? If we try to have this, and we try to have this region first, that would block this, so that doesn't work. If we try to have either of these regions, that doesn't work either. because these two would be blank no matter what if that's the case. So this doesn't work either. So it has to be either here or here is a region. So either way, these 6 cells are part of a region here. So we need to have here and here be borders. If that's the case, these cannot be the same region. So this has to be valid as a region. And therefore, none of these can work, right? If either of these worked, this would not have a valid region. I guess no, this could be a region. So this is not valid, but this could be a region or this could be a region. If we have something like this, we need one of these to be a valid region. And either way, so okay. So it could be here. So it still could be this one, and then this is valid, right? That works. Hmm. What we do know, though, is... So if it's here... Okay, it could be something like here, and then here. We know these two have to be part of the same region. You could have something like that. I don't know if we're required to have indices here. We may not be. One of these definitely has to be filled. Actually, one of these has to be filled, and one of these has to be filled, at least. That's interesting. One of these is filled, one of the... Well, we know that's filled, at least. Interesting. Okay, so say we had... Actually, I don't think this can ever be a region, right? Because, well, I guess it could, technically, if we had this. Right? If we had that region, that would be okay. What about this one, then? Okay, so the problem with this is none of these would be filled. So if that were the case here, I guess you could have a region here. Okay, no, that wouldn't work. These would both be... So, okay. If you have 2 of any of these in the same... You don't necessarily have to have them in the same region, right? But either these 2 are going to be in the same region, or these 2 are going to be in the same region, right? So if these were both blank, the only way to have, you cannot have regions here that satisfy this. If both are blank on their, like, one side, right? So if it's both blank here, there's no way you can get regions to satisfy these because you're going to have these two are going to be in the same region or these two are going to be in the same region. We're guaranteed that. So you cannot have blank blank, right? If you have blank blank, you're guaranteed that these two have to be the same digit. And that's not allowed. Okay, that's where it is, right? If you have blank blank, you know that this is guaranteed to be the same digit in the same column, and that's not allowed. So you always have to have at least one of each on a zipper line. That's actually very interesting. So there's always at least one of these here and here, right? On a zipper line. This one specifically has to work this way, just here or here, because of the way this has to work. Because this has to be separate than this. These have to be the exact same digit. So it could be something along here, or it could be something along here. Oh, that's interesting. So because we have something like this in here, one of these is going to have to be not part of a region. Guaranteed. So say we started here, right? Actually, that's probably the harder one. Let's start here. So say this was a region here. Then this would have to be part of a we know this would be a region then. This would have to be part of a region. So it would either be here. So it'd be either here as a region or here. Okay, so this as a region would guarantee neither of these could be part of a region. So neither of these could be part of the region, therefore this would be exactly the same as that. This could not be blank. So this would not be part of this region. So this region would have to be either here or here. Okay, so if this is a region here, this is blank, this is the same exact digit as that. So the region would either be here or here, essentially. So if that's a region, we know we have something here or here. Because this would have to be, well, could not be blank, because we know that's blank. So this would not be blank if that's the case. And it would have to be here or here. Therefore, this would have to be in a region. And it could be, where would that be? It would have to be either here, 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 or here, I believe, right? It has to include that as a region, if that's the case. So it has to be either here, 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 or here. Okay. Um... Hmm. This cannot be the only digit here. If this were the only... So, okay. What about this arrow? Obviously, one of these has to be filled. If this were the only one filled, it would be exactly the same as that, and therefore there would have be a contradiction in the deconstruction rules. So this one must always contain this as a digit. It could be both of these, though. But this one is always a digit also. And it could be filled here. Or it could not be also. So you can't have 2 be blank here, because that would force that to be blank. You can't have... There must be 1 in each, at least in each side. So either this is filled or that's filled. And you cannot have... One of them's blank. We know at least one of these is filled. At least one of these is filled. You cannot have blank blank, so therefore you can't have both of these filled. And you can't have blank blank here, because then one of these is filled. So one of these is always filled. Okay, so we have a guaranteed one of these is filled, one of these is filled. Actually, yeah, what happens there? The question is, can you ever have essentially... Huh. I don't think you can ever have that, right? So can you ever have a pattern where it's something like here, here, and then here? Don't you always have to have one of these zippers essentially be non-duplicative, right? You have to actually add up to the central zipper. I think just because of the deconstruction rules, because you can only have 9 3x3 spaces, you can't have essentially one digit be the same as this, and one digit be the same as this, and then them both be blank. The other ones be blank, right? Because if you... Let's try that, right? Say you... Therefore, if that's a case, one of these is blank. So say we had one blank here, and then the other is blank in the other spot, right? You can't have 2 blank in the same row or column, because they would be the same digit. But say we try to have one blank and then the other blank on the other side. So then you guarantee this has to be the region. You guarantee that one of these... Yes, so this is never the case. You guarantee... So you have to have a 3x3 region which fills one of these, right? And therefore you would always have something like this. Or this. And by definition, then, this wouldn't be blank. So you can never have, essentially, essentially, one of them be blank. Sorry, both of them be essentially the same digit as this one. You have to have a 2x2... you have to have 2 of them add up to one of them, essentially. Just by how the deconstruction rules work. So it's the same with this. All the zipper lines here. You can never have essentially them be... One of them is going to be filled, right? This is interesting, though. Say you had something like this. So if you fill in this, the problem then makes this that this is 3 digits already, which add up to 1. 3 unique digits adding up to 1. So if that were the case, then this essentially has to be the region here. So say we had this region, and then we had... Oops. That went by more than 3 by 3. Say we had this region. You would have to have a region here be pink. Therefore, this would be a region here. I don't know. Make it dark. This would have to be in a region, and that's not allowed. So, this is never a region. Start here. You could potentially have something like this. So this can never be a region here. Start. Okay. Okay. So if we tried doing this way. So if we started here, so say that was a region. Therefore, you have that as a region. This would have to be part of a region. So it would be either here or here is part of a region. Does that work? What would that guarantee? Okay, so if this is the case, if this is a region here, that would guarantee this has to be part of a region, and this has to be part of a region, because none of these can be part of a region, if that's the case. So this would be part of a region, this would be part of the region. This would not be the same part of the region as that. We also... Okay, so this is part of a region. This would have to be one of these 4 to start with. This would also be part of a region. And it would be part of... This would also be part of a region. And then we know... So we know this would be part of a region. These would also be parts of regions. We know this would be part of a region. Because it would have to be one of these 4, right? So it would have to be either here, 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 or here, which is part of the region. Interesting. Say this was another region here, right? If that were the case, this could never be part of a region, so this would have to be different from there. That's fine. It would be one of these 2, then would be part of a region. Hmm. You could actually have 2 and 2. That's possible also, right? That these two add up to essentially this digit. That's possible. Ah. But if this were a region, you could not have any of these be part of a region. That's interesting. If this were a region, then you'd have to have these two be part of the same region. Because you can't have anything start here. You can't have it. Say they tried to be separate regions. This would then be have to start not conclude that, so it would have to be like here, and then that would overlap here, or it would have to overlap here, which is a part of another region. So this would be part of the same region, and you could not go here, so it would have to be this one, which then requires this to be a region. So that does not work. So you could not have this one be a region. You would have to include this then, at least. So say this was a region, right? Then you still had this. That seems fine. Um, hmm. Hmm. Um, so this is actually an interesting state here. Oh, is it based off of where the cursor is, not where you click? I think it's based off where the cursor is. Well, good thing to learn right now, unfortunately. It's based off where the cursor is. Oh, man, so late. So you can zoom in based off where the cursor is. Okay. Well, I guess I'll give that as a hint to people if they want to play, if they want to actually try this. This has definitely been a hairy solve. Well, it's basically like I think it's like essentially well you have 10 grids and then you have the bosses for every grid. So that's 18 essentially puzzles you're solving. So there's a reason why this is taking so long. Um hmm. Hmm. What else do we have? Let's go back to this. Trying this. Because that cannot be this is blank, guaranteed. This has to be different, but this is guaranteed to be something. This is guaranteed to be something. And it's the same digit as that. This is the same digit as that. Therefore, we're guaranteed to have these three. We're guaranteed to have these two. That doesn't tell us very much. Actually, we're guaranteed to have these three. We have, then this would be a region. This would have to be a region here. Oh, that's a good question. Okay. For these two, can they ever be part of separate regions? I think the answer to that is no. So try to make it a separate region, right? I guess you could, technically. Yes, you could. Okay, so they could be separate regions if it goes something like this and this here. Right? Or it would be something like this and this. Okay, let's try that. So say we try to make these separate regions. You could have something like this and this. That does work. Then this would have to be, since this is not part of a region, this would also not be part of a region. So you would have to have this as a region here, which would mean that's part of a region. If these are part of the same region, it can never be there. Right? Oh, this is actually very interesting. So then again, we know this has to be part of a region, period. Because if this is not part of the region, this is exactly the same as that digit, and that's not allowed. So this could add up with this one to be the same as these digits, or it could be this is separate, this is not in part of a region, and these are the same as this, right? That digit. Here we know there's at least two adding up to add to this one. If this is the same region, again, it cannot be here, because if it's here, that would mean these are both blank, because there can't be a 3x3 region that contains them, and these are both blank, which obviously doesn't work. It could be this is a region, so this is a possibility for these two, or it's possible these are separate, right? So if this is a region, these two add up to this digit, and we could have one separate here and one separate here, or they both could be actually the same, or they could also be filled in, right? So because of this interaction, these two have to be either part of the same region or part of different regions. But if they're okay, so what happens if they're part of different regions? Can this ever be essentially a separate region? No, because of similar problems, right? Well, not necessarily. This actually could be a region here if you had something like this and then this would be part of a region, right? Or this would be part of a full region here. But that Okay, let's see what happens if we have this as a region, right? If we have that as a region, one of these two must be part of a region. Okay, that seems fine. Hmm. Actually, huh. So this is valid as a region for these two. Hmm. What are the other valid regions for here? It could be here. Can it be here? Maybe. So the only one that's not valid is this one here, because that blocks these. You could have something like that. No, that's not. Well, you could have something like that in there. That does work. So this is not valid. This is not valid because then these two would be, well, this one be blank, guaranteed. So you could not have something like here either. Then can you ever have something like this? No, because that would block this also, and these two would have to be the same. So this doesn't work, this doesn't work, this doesn't work, right? If you have here, this is blocking these two from being in region, so they would both be blank. If you have here, that blocks this from having a region, this from having a region, so these two would be the same. Same here, if you have one here. So this could be the start of one. It could be here too, technically. And I think these two are valid as the upper left corners also. Actually, can it ever be here is the question, right? If you try to have it here, this then can never be part of a region. So if you had it here, that blocks this from being a region, so it would have to be guaranteed to be here, but then this would be blank and that would be blank, so that's not allowed. So this is not valid as a region. You could still have here as a region. Wait. Right. So say you had this as a region is kind of the question, right? So you have that as a region. You cannot have this be part of a region here. One of these has to be filled. One of these has to be filled. So you know one of these is filled, one of these is... At least one of these is filled, at least one of these is filled. Right? At least one of these is filled, at least one of these is filled, at least one of these is filled, at least one of these is filled. At least one of these is filled, at least one of these is filled. This is already filled, so that's fine. This is already filled, so that's fine. One of these two has to be filled. 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 So you did have something like this. You could have something like that. Okay, let's do it that way then. Let's try these. So say we had a region here. That would mean these three cannot be filled. One of these two has to be filled. So therefore, this is definitely part of a region. One of these two has to be filled. So we would guarantee we'd have to have something like this. But we don't know whether it would be included there. This would be part of a region, so this could never be part of a region. Therefore, this would have to be part of a region, which would mean this is filled. The problem is this would have to be part of a region, and this would have to be part of a region, if that's the case. Right? Okay. So again, if this is a region, this has to be only part of this region here. Right? Because it cannot be part of this region, because then that would block this from being a region. Well, wait, hold up. Why can't that be? Oh, because it would block this from being part of a region if it's here, right? And therefore these would be the same and they're part of the same region, right? So that's why. These would have to be part of the same region. Okay, so this would be then, so this would force this to be a region, which would mean this is blank, so this would have to be part of a region. So you'd guarantee to have this, but this could not be part of a region. So this would be blank, and these would have to be guaranteed to be part of the same region, because you cannot have... It's specifically because you can't have this as a separate region from this, right? So these two would have to be part of the same region, and therefore that would fail. So this specifically, this cell does not work. What about if we had this as a region? If this is a region, then similarly, this still could not be a region. This would have to be a region. This would be blank, so this would have to be part of a region here. And these two would have to be in the same region, so it would have to be this specifically. You could not enter this as a region. This is valid, actually, so far. This would be part of the top region, then. This could not be part of a region. So far, this is okay. This would not be part of a region. This is fine. This is separate from that. So these two add up to here. That's fine. Huh. Okay, that seems kosher. Is there any other way we can construct that then? Don't know. Um, if this were a region, that would mean this has to be this has to contain, okay, this, wait, does that work? I guess it would mean that this has to be a region here to make this different from this. Therefore, this could never be part of a region. This would always have to be part of a region here, so it would have to be, well, it could be here, I guess, technically. Okay, let's try this one again. Maybe we can eliminate something here. I don't know if we will be able to, but... If this is a region, we have to have this as a region to make that, essentially, it be part of a region, because this one can no longer be part of that region. So it would have to be here. These could not be part of a region. This would have to be part of a region. So all of these 6 would be part of a region. This would have to be a region here. Either these 3 or these 3 would be part of a region. We're not sure which. These 2 would have to be part of a region. So it would have to be here, right? So we guarantee that. You could not have a region that includes this. So this is blocked off. That's fine, because then this is the same as that digit. You would have to have one of these be part of a region. So this one would definitely have to be part of a region. It's either here or it would have to be here, right? So this would be part of a region no matter what. This would be part of a region, that same region. So because this is part of the same region, this would have to be filled. Well, we already know that has to be filled. Since this is filled and not part of that region, this has to be the same region. So these are all filled. We don't know if it's here or if it's here. Oh, this doesn't work. How can you fill in 9 here? You only have 2 at the bottom, right? You can only fill in this one. And you can't fit in 3 by 3 squares here then. So that does not work. Because again, So that's specifically if you have this, right? Because that forces these to be in the same region, right? And if that's the case, this being 2 already blocks this from being part of a region. So you could have something like this. I think you're almost always guaranteed to have 3 regions here, right? If you do not have this as a region, how does that ever work? So I think this can never be part of a region, and this can never be part of a region. If we try to have both, either of those be part of the region, even this is problematic, right? Because, okay, so the problem is we need to have in this 11 by 11 area, there has to be 3 by 3 areas within this bottom 5 tier, right? Guaranteed. Because you have to have, since it's an 11 by 11 area, you're restricted on where you can go, right? So if you don't have 3 within this area, this 5 by 11 region, if you don't have 3 there, the problem is that the problem is you can only have 6 in the rest, right? Because you have 6 rows left in the remaining. Yeah, you have 6 rows left, and you have 11 areas, 11 columns. So therefore, you're restricted to have only 6 3 by 3 squares. So in this 5 by 11 area, you have to have 3 3 by 3 squares. But if this were an area, the problem is that this can never be part of that region, right? This area also basically says you cannot have in this 5 by 11 area because you restrict this. So say we have here, right? Say we have it here. This 5, well, it's restricted because we don't have this anymore, right? In this area, we have to have at least 2, or can we have 2 is a question. That's really the question, right? And I think the answer is no. How do you fit 2 3 by 3 squares in this area? You can't, right? So specifically, we try to make this, like we try to make it here, there's no other 3 by 3 area. If we try to make it here, there's no 3 by 3 area. If we try to make it here, there's no 3 by 3 area. Same for these, right? They always will block off other ones. The question is if what happens. So therefore, this is the case. So if that's the case, then also for this area, can you have 2 3 by 3 squares? And this is the reason why it has to be this area, is this is never part of a region if you have this, right? And I think the answer here is no too, right? Because, well, it's the same exact space. So therefore, you cannot have a 3 by 3 area that way. So this, we then know, is ruled out as a top left corner. The question is, so then this is always part of a region. So this is always part of a region then. The question then can be, can this ever be an area? Maybe? I don't know. Actually, I think the answer here is no also, right? So this 5 by 5 area, they all require this central cell. And so basically, anything that has 3 a 3 by 3 area here that includes this, that guarantees that this 3 can never be part of a 3 by 3 area. And if that's the case, for the central 5 area here figure, that means you can only ever have one box in it. This necessarily will cause problems because it cannot be part of essentially this bottom 6. Sorry, this bottom 5, technically. And so it will block essentially these areas from having 6 3 by 3s areas here. It's part of the 6 3 by 3 squares, but then it blocks this from having a 2 by 2, three 3 by 3 areas in the bottom 5 rows. I'm not sure if this is making sense. This is all geometry here, but essentially, if you have something here, it blocks this from ever being essentially part of a 3 by 3 area. Therefore, it will split the area of the bottom 5 rows, which it is not technically a part of. So basically, and therefore, it has to be considered part of the 6 3 by 3 areas in the above 6 rows, right? Because it's blocking a row here. And there's no other place for this to contain a 3 by 3 area unless this is part of the 6 cells there. Or 6 boxes. 3 by 3 boxes there. I'm not sure if this is making sense to anybody. How to explain it even better? Is there a way to explain it? I don't know. This is something that I'm just grokking intuitively. But say we constructed here. Say we tried to have 6 3 by 3 area. Okay. Let me see if I can put it this way. Since this is an 11 by 11 area, you can never have 4 3 by 3 cells occupying the same 3 columns, right? So, even if you had something along the lines of, say, this 9 by 9 area here, be essentially all 3 by 3 cells, right? So these are all valid. You cannot use any of these. You can't use any of these to form essentially another 3 by 3 area. So out of the remaining area, how do you form 5 more 3 by 3 boxes? And the answer is you can't. Right? Even if you tried to smush them, right? So say, because this is essentially a 3 by 3 area, which takes up part of the upper 6 rows and part of the bottom 6 rows, and it forces this not to be a region, you have a problem here. Right? Try to form 5 3 by 3 areas with this without this being a region. Right? Because the problem is you need to have essentially 2 3 by 3 areas in these spaces. Otherwise, you're essentially blocked off. And this specifically blocks off essentially the central lower 3 by 3 box. Right? You can only have 2 in this space. I think, okay, that's the way of putting it. So in every 3 by... Okay, so this cell, in every 3 by 3 space, in every five-row area, you can only have three 3x3 boxes, right? At most. Just because you have, it's 11, right? You have 11 columns. You can never have 12 columns in the 12 columns with four 5x5 areas. Sorry, four 3x3 boxes in that area. So because of that, you have to guarantee three 3x3 boxes within a 5-row area or a 5-column area. Because this blocks essentially the other parts, right? Where in this 6x6 area can you have six 3x3 cells? You can't, because this part blocks it, right? This is blocking essentially for this three row area. It's blocking essentially an area, space that you could have a 3x3 box, right? So in this 3-row space, you can only have three 3x3 boxes. Okay, that's probably the better way of putting it. In this 3x11 area, these 3 rows, you can only have three 3x3 boxes here, right? In this 3x3 area, you can only have three 3x3 boxes. So this counts as that because it's containing 3 of the rows, 3 of the columns in this 3x3 row area. So because of that, this restricts essentially this area from ever being a 3x3 in a 3x3 region, because these two with these 3 would have to add up to this single digit, which is not allowed. So because of that, this 5x11 area is essentially blocked into a 5x5 box and some smaller area, which is less than 5x5. Well, in a 5x5 box, you can only have one 3x3 box there, right? They all have to contain the central digit. And therefore, you cannot have two 3x3 boxes in that 5x5 space. So therefore, anything that contains more than one of these essentially cells here blocks this from ever having a cell. From ever being part of a 3x3 region. And because of that, that will always block off essentially this 5x5 region from separately as this 5x5 region. So you could only have one 3x3 box in any of the bottom 5 rows then. So that would be 2 total, but you need 3. So therefore, this cannot be a valid region for this one. This cannot be a valid region. This has to be the start of this region here. So we know, guaranteed, this has to be essentially a region. And therefore, all of these are valid. Therefore, this is no longer part of a region. This has to be part of a region here. So it has to be here. So this is all part of a region. And it's here. That makes this not part of a region. That makes this not part of a region. So both of these have to be part of regions here. We don't know about this one. So this is not part of a region. This is not part of a region. So both of these have to be part, well, this one has to be part of a region. So since this is part of a region, we guarantee this has to be part of a region also. It cannot be here as a region because then this doesn't be part, this is not part of a region. So this is not valid here. I think then this has to be part of this region here. Can it ever be part of another region? It can't be part of like this region, because that would eliminate those as possibilities. So these are part of a region. We don't know if it goes here to here or if it goes here to here. Right? So it could be like this. So this is always part of a region. It could be either this one and this is part of a region, or it could be this one and then this is part of a region. We know this is never part of a region, this is never part of a region. This has to be part of a region. One of these two has to be part of a region. It could be here. Okay, we don't know about this. So this is still one of these two. Okay, so this has to be part of a region. This is part of a region. So we have 3 this way. So it has to be 3 this way. This is then the end of that region. And it could be part of this, or it could be part of this one. This has to be a part of a region because, right, we know this is part of a region because you cannot have 2 of these being blank. And we know this is blank because then these would be the same digit. So this, since this is part of a region, this is not part of a region. These 3 have to be part of a region then. Since these 3 are part of a region, it has to be a part of a region with these 3. So we have these 2 essentially as part of a region, and it's either here or here where it's the boundary. It could be these 6, or it could be, sorry, these 9. So, okay, we know this is a boundary, these are boundaries here. It could be these 9 here, which would then force these 9 to be part of a region. Or it would be these 9 here, and these 9 could be part of a region, or these 9 could be part of a region. So either way, these 2 are definitely guaranteed to be part of a region. One of these 2 is guaranteed to be part of a region. It could be here, could end here. We know either this is a region or this is a region. Okay, so what is not part of a region? We know these are not. We know these are not. This cannot be. Because if it were, then it would be this is a part of a region, but this would not be part of a region. So one of these 2 is. One of these 3 could be. We don't know. This cannot be the start of a region, and this cannot be these cannot be the start of a region. So these are not part of a region. This is not part of a region here. It could be part of a region here. This is never part of a region. Because it's always going to include these two. Right? One of these two has to be, one of these two has to be, one of these two has to be, one of these two has to be. Hmm. I guess you could have something like that. That's possible. This is the same digit as that. These two add up to this. 3 of these add up to this. Therefore, this is always 6, 7, 8, 9. We're not sure which, though. These two add up to this. This is the same digit as that. So let's mark it as A, I guess. So this is A, this is A. This is B. Let's make it, I guess, lowercase. Or not lowercase, but this is the same as this one, because this is not valid as region. You could have something like that. That's valid. Huh. What are the valid regions that include these two? Obviously, these are not the same as this one. So this could be the start of a region if this is a region. It could also be these two, I think, right? Yeah. This one and this one. Those are the only 3 then. For this one, similarly, it cannot be here. So these 2, I think, are the possibilities for this region here. It could be here. Okay, we need one. Either has to be here. So we need this 3x3 area. I think this 3x3 area has to be part of a region. If it's not, we have the same problem, right? If we block this off from being part of a region, you have a 5x5 area here, which must contain 2, which can only contain one 3x3 region, and then we have one 5x5 area here, which can only contain one region. So that's not allowed. So these 3 have to be part of a region somewhere. And since these 3 are part of a region, it can be either here, here, or here is the start. We're not sure which. Upper left, essentially. That means this is always going to be... Okay, well, 9 cannot be here. 3 has to be here, so 3 cannot be here either. I don't know if that's a region or not. Though the thing is, with these areas, this is at least 3... It cannot be 6. Sorry, it can't be 5. So this is 3, 4... 3 could be in the same area, I guess. 3, 4, 6, 7, 8, 9. And this is 3, 4, 6, 7, 8, 9. Because you can't have 1 and 2, and obviously they can't be 5. This, though, is in next to 2 unique digits on a 3 by... So this can't be 4 or 6. So 3 can only be in 3, 7, 8, or 9. So 3 in this column can only be one of these 3 digits. 9 can be... This is only next to 1, so that's potentially fine. This could be 3, 4. So 9 can be 3, 4, 6, 7, 8, 9. So 9 has to be one of these 6 digits. Since this indexes on it. The thing containing this digit could technically be here. So this is fine. It cannot be any of these. So this one has to be any of those 3 here. So this is part of... This is going to be valid parts. So it's either here... So it's either this 3 by 3 area, this 3 by 3 area, or this 3 by 3 area. What about here? This one, it could be a lot of things, actually. This could be all 9. It could be all 9 spaces here. Actually, it cannot be this one, right? If it's this one, those 2 get blocked from being an area. These 2 get blocked from being an area. So it could be any of these 8. Right? It could be here, and then this is an area. That's fine. Actually, can it be this? No, because then this would be blank. Okay, so these 2 cannot be part of the starts. Because if it's here, this is no longer... This has to be blank, which would force both of these to be the same digit. Okay. What about here? That seems okay as long as these are essentially the same. So this could actually be here, but it could also start here. That's valid too. Okay. This is 6. This is 6, and these are both valid. Well, this is 1 through 6, which means 6 has to be one of these. That doesn't really tell us much. This is 1 through 6 to add up to, at most, 9. Either this is something or this is something. We're not sure which. Right, so it could be something like this is an area. Actually, is that the case? Can this ever be an area? So say this was an area here. Oops. Let's make it orange because dark is essentially not possible to be an area. Well, we know these have to be essentially part of it. So this can only go up to here, which would mean this is blank. And this is then the same as that digit, and it's the same area, so that's not allowed. So this cannot be actually part of that area. Let's just keep this, I guess, and let's just remove this. So this has to be part of this 3. So this is definitely either these 3. So it has to be these 3 by 3 box, this 3 by 3 box, or this 3 by 3 box. One of these two must be part of a region. Therefore, it's always guaranteed that this is going to be part of a region here. So this is always part of a region here. So it cannot be down here, right? Because we know one of these two is part of a region, and it specifically cannot be here, right? If we try to have a 3 by 3 region here, the problem is this doesn't extend far enough, right? It'll only go to here. This is blank, and these two would be part of the same region, and they would be the same number. So it can never be part. This is part of the same region. This doesn't work either for the same reason, right? This doesn't extend far enough. It just goes to here at most, and this would be blank, and these would be part of the same region. So these two can never be part of the same region at all. Basically, yeah, they can never be part of the same region because this can only extend all the way to here, and this would be blank if that's the case. And one of these two must be at least filled. So therefore, this is guaranteed to be here. So it's either here or it's here. Therefore, it can never be this as a 3 by 3 region. Therefore, this has to be part of this lower region here. And because of that, this can never be part of that region. This can never, none of these can be essentially the start of that region because this would not have a region then. So it has to be one of these. So this is always going to be filled because these two have to be part of the same region as this. It's either going to be here. One of these two must be part of a region. I guess it could be like that. That's possible. So either this is part of a region or this is part of a region, or both. We don't know. Huh. Okay. If this were the region, so say this was the region here. If that was the region, these two would have to be filled because these would have to differ from that digit. If one of them's not filled, then this would have to be the same as that digit. Therefore, these would have to be filled, but that's 7. That would form 3 3 by 3 boxes here, which is not allowed because this is the one 3 by 3 box in the lower right. So this cannot be a region. Therefore, it has to be something like this. So we know This is the edge of a boundary. This is the edge of a boundary. So again, like the reason why this is the case, these are all part of the same region. So these have to be different from that. Therefore, these must be filled out. But we only have two 3x3 regions possible to fill that out. And it extends only to here. So this would have to be blank. These would be in the same region. Therefore, that doesn't work. So therefore, this region must start either here or here. It could be here. But again, then you have the same problem, right? These would be in the same region. This would be blank because this can extend only at most to here. And therefore that can't be part of that. Therefore we know this is the start of that region. And it must go here. So this is a region here. Remove that. Whoops. Remove the blue. So one of these two has to be part of a region. We're not sure which. Okay. What cannot be part of regions? These can no longer be part of regions. These can no longer be part of regions. You could have this one here, this one, this one, this one, this one. I mean, it could even be both of these are filled up. Oh, wait, hold up. Say this was a region here. You have a similar problem. So say this was a region here. That leaves this being blank because this has to be part of essentially this region. So this would have to be filled, but it couldn't be part of any of these two regions here, right? This extends only to here. So it would have to be part of that region if that's the case. And if that's the case, then these would be the same digit. So if this were the region here, this would be blank. This would have to be filled, and it would have to be the same digit as this, but this couldn't be part of either of these two regions here. So it would have to be part of this 3x3 region, and it would be in the same region as this digit, which is not allowed. So this is not the upper left corner. This has to be the upper left corner here, which makes this a region here. These are not valid regions. Therefore, this is a valid region. So it must continue to here. So it's one of these two. So this cannot be part of this region here because this has to go to here. This is the same. This is D. This is D. So it has to be the same as these two. This is not then the upper left corner. This has to be the upper left corner. And it has to go to here. These are not valid. So this can't be 6 here. Therefore, this can't be 1 to reference the 1 here. These are both filled. So one of these does not have to be filled. At least one of these does have to be filled, though, but we don't know which one. This is the same as that. This cannot be 5, because therefore this can't be a 6 here, because 5 can never be on a German whisper line. Hmm. Okay, 9 can never be here. So this cannot be 8. 9 can't be here either. This can't be 7. So 9 could be 3, column 4, column 6, or column 9. If this were a 6, the problem is it would have to there would have to be a 1 on next to it on a German whisper line. This could not be 1, so it would have to be here, and it would have to be part of the same area. But then this would have to add up to 6, 2, and 1, which doesn't work because then this could not contain a 1, right? Because this would have to be 6, which would force that to be 1. The valid 3 digits here would never be 1, 2, and 6 then. And therefore, it'd have to be at least 2, 3, and 6, which is 11. So this can never be 6. This is a low. So this is 2, 3, or 4. Which means it's next to 2 highs. Okay, so what happens then here? If this is 2, 3, 4, and these are the this is the box. These would be highs, this would be low, this would be high. If this is the box, okay. No, hold up. This would be low. So if this were the box, these two would be high, these two would be low, and this would be high. So this would be 7, 8, or 9, and this would be a low, 3 or 4, next to a high. So that's possible. If this is the box, then this low would be next to a high. Okay, so this can never be 6 here. If this were 6, four, 5, 6, 7, 8, 9. If this were 6, this would have to be 1, or this would be 1. But this can never be 1 here because of where it's indexing. So this can never be 9. That's interesting. Therefore, this can never be 6. So again, if this is the area, this is high, this has to be a low, which is 3 or 4 on the German whisper line. This would be high, this would be low, this would be high. And that could work. Otherwise, if this is the area, this would have to be high, so this would be 9. And that would be valid, so that would be 9. And then this would be high, and this would be low, so that would be 3. Okay. Both seem reasonable. This cannot be 6, though, so therefore this the 9 cannot be there. 9 is either one of these two, or it's here. Hmm. We know this is a boundary. We know this is a boundary. That's all we know. Um, hmm. Okay. So this is also 6, 7, or 8 here. B then would have to be one of these 3 digits, but we're not sure which. Oh man, this is tough. Hmm. So if it's this space, it has to go. That has to be with essentially this one, right? And then this digit would be the same as that. Therefore, it would be here. That seems fine. Oh, this sees 3 here. And we have those digits. So this is 1 through, well, we already knew it's 1 through 7. This has to be 2 through 8, and this is 3 through 9. But this can't be 5, obviously. Well, this digit, if this is 3, this has to be 8. So this cannot be 6 or 7. This could be 2, 3, or 4 also, though. So if this is 3, this is 8. If this is 7, 8, or 9, it could be 2, 3, or 4. This is 1 through 7 also. This could be still 1 through 9. This is 1 through 6, 2 through 7, 3 through 9, sorry, 3 through 8, and 4 through 9 here. Okay. This sees 3. We don't know how that works. This sees 3. We don't know how that works. This cannot be 6 because the 6 has to be either in 2, 3, or 4. Cannot be 5 here because of the German whisper line. Can't be 6 because we tried having a 6 here. That would require this to be 1, but then this cannot add up to 9 here. This can't be 6 here. If this is 3, this would be 8. This would have to be 9. That seems fine, and then this would be 9. Yeah, that seems fine. If this was 7, this would have to be 8, which would force that to be 8. So this can never be 7. Right, so if this is 7, this has to be 8 to be seen. This has to be 8 to be added up to be 1, 7, and therefore this would be 8. The problem is we'd have two 8s in the same region, same box, so that wouldn't work. This is at least 3. This is at least 3. This is at least 3. That's at least 3. But that doesn't tell us anything. Actually, this is at least 2. So 2, 3, 4, 6, 7, 8, 9. Okay, so one of these has to be a low here. One of these also has to be a high. So this can never be 4, because if this is 4, you have all 3 lows, all 4 lows on the thermometer, and this can't be low. This can't be 6 because of the same reasoning. Actually, it can't even be 7 here. If this is 7, 8, 9, this is 6, and therefore this would have to not have a high. So this can't even be 7 here. If this is 6, same problem here. You have this is 7 or 8. One of these is 7 or 8, with that being 9. And this would not have a high. So this cannot be 6. Therefore, this can't be 5. We know there's a 1 in one of these 3 spaces. Or one of these 4, technically. We just don't know which. Obviously this can't be 1 then anymore, because it's at least 1, 2, 3, 1, 2, 4, 1, 2, 5, or 1, 3, 4. We're not sure which. Where's this digit? I guess it could be either of these. That's fine. Cannot be here, though. Okay, so D has to be one of these 3. Oops. D has to be one of these 3 digits, because it's here, here, and cannot be, so cannot be here, cannot be here. It has to be one of these. C has to be one of these 3 digits. That's interesting. We don't know where A is. Actually, we do know. A cannot be any of these, so A has to be one of these 5. That doesn't really tell us much. B is not one of these, so B has to be one of these 3. Okay. Do we know anything else? If this is 3, if this is 3, this has to be 8 and 9. But then that would break this skyscraper because it would not see 3 digits. Therefore, this cannot be a 3. Ah, very clever. So this has to be high. This has to be low. These are low. 1, 2, 3, 4. This has to be lower than that. So this is 1, 2, 3 at most. This 3 must add up with at least 3 to add up to 6. This is a low. This is a low. This has to be a high. Therefore, this is the region. Because this is low. This has to be high. Because again, if this were 3, this would be 8. But the problem is, this would all have to be 9 to make sure that this German whisper line worked. And therefore, this skyscraper would not see 3 skyscrapers. So, this has to be high. Which means 3 is in 7, 8, or 9. This is low. This then must be high. Because you have to counter this. So this is 7, 8, 9. This is 7, 8, 9. This is next to 2 unique digits on a German whisper line. So this cannot be 4. It's 2 or 3. This has to be a low, so it cannot be 9. So 9 is in 3 or 4. Therefore, this cannot be a 9 here. 9 is in 7, 8, or 9 here. This is 7, 8, or 9. It could be 7 and 8 here. That's interesting. Six is in 2 or 3, so this cannot be 6 anymore. Okay, so this is a boundary here. Again, these are... This is a boundary here. This is high, high. This is not a valid region. So this is 1 through 4, 7, 8, 9. This could be 4. You could have 9 here and 9 here. That's potentially valid. 3 and 4 are here. So this is 3 or 4, which means this cannot be 7. This is a low. These are lows. This is 1 through 5 here. This is not valid. Two, 3, 4, 7, 8, 9. One of these is high, one of these is low. Okay. What else do we know? So we got that Scrypeeper. We don't know anything about this Scrypeeper. We don't know anything about this Scrypeeper. Oh, A cannot be here in this region, and A cannot be here. So A has to be one of these 3 digits. That's very interesting. D could be the same as A. Okay, so A in this region is here. Because it can't be here, it can't be here. A in this region cannot be here, cannot be here, so A is here. A could be here, or A could be here. In this region. If this is 7, this would have to be 1 and 2, and therefore this would be 3. And then this would not see each of these digits. So that doesn't work. So this cannot be 7. Can this ever be 3? If this is 3, this is 4, that's 9. Can this be 3? If this is 3, This is 2, this is 1, that's 4. This is 9 then. Interesting. Um... So this can never be 7 here. 8 it could be, technically, right? Then you would have... So if this is 9, this could be 8. Which would mean 3 is here, this is 4. This would be 9. This is tough. Okay. We have a 1-to-2 ratio, potentially. Oh, this can never be 3. If this were 3, this would have to be 1 and 2 here. Well, no, it could be 1 here and 2 here. And this could be 2, 4. That could be valid. Yeesh. Hmm. The only way this is, well, that could be 1, 2, 3, adding up to 6. I was gonna say the only way this is not 2 is if that's 3, but this could be 1, 2, 3. So that could be possible. 7, 8, 9, 8, 9. This is 3 and 4. Oh, that's actually interesting. So if this is 9, this is 3. If this is 4, this is 9, which forces that to be 9. And then this becomes 8. Yeah, what is the... Okay, so 3 can never be here. That's interesting. So 3 is one of these two. It's either 8 or 9. What happens if it's 8? So if it's 8, that means this is 3. This is 9, which makes this 4. So this is 9. This has to be 5 then. This can't be 8. This can no longer be 4. This can't be 4. This can't be 3. This can't be 8, obviously. So this can't be 7. This can't be 3. So this can never be 3 then either, right? To add up to 6 or 7, it's 1 or 2 here. This can't be 8. This is 1, 2, and 3 here. So that leaves 4, 5, 6, 7 here. This can't be 5 because of this 5. This can't be 4. It's a 6, 7 pair, which forces this to be 1 and 2. This is greater than 5. This is greater than 6. So it's 7, 8, 9, 6, 7, 8, 9. This is a high. So far, it's looking fine. This cannot be 5 anymore. This has to be 1 and 2 here. This can't be 9. That's looking okay. This 6, 7 pair eliminates 6 and 7 in the rest of the row. This cannot be 7, therefore this is 8. Oops. This is 8. This is a 4, 5 pair. So far, this is looking fine. This is 1 and 2 here, and it's with 3 or 4. This could be 2 or 3. That's fine. This is at least a 3 here. So this has to be at least 3. One of these is a 3, the other one's at least a 5. So this has to be at least 5. Therefore, this becomes high, which makes this a low, which would make this high. Okay. And these would be 1, 2, and 4. These would be 3 through 9. So far, it's looking fine. Not great, but fine. This could not be 1, 2. It cannot be 2, 4, because that would eliminate 2 possibilities for these 2 cells and leaving this with both of them with the same possibility. So it's either 3, 6, or it's 4, 8. It's possible. That looks like it's fine. So that's no contradiction there. Okay, that can't be 3. We know it's 8 or 9. So what if this is 8? If this is 8... Actually, let's make this... Yeah, if we make this 8, this has to be 3, which makes this 9. So this can't be 3 here. That doesn't mean anything. Okay, these are not part of any region. We know one is one of these. Oh boy. Huh. Hmm. So obviously C cannot add up to D, with D also adding up to C, right? So only one of these could be possible. It could be neither of them are possible, and D's here and then C's here. Uh, what else do we have? Where else are we going with this? This is 2 through 9. That's just not helpful. So this is 3 through 9. This is 3 through 9 because it's two unique digits in the same box. This we don't know. So we know this is A. This is, I guess, 2 through 9. We have 1, 2, 3, 4, 6, 8 here. And here. Hmm. This must be smaller than this. And we know this is 2 through 9. This is 1 through 8. Because it must be... This must add up with this to add up to here. That's all we have. This must be smaller than that. So this is 1 through 8 also. This is 1 through 8. This is 3 through 9 here. This is 3... Oops. Yeah, sorry. 3 through 9 here. This is 3 through 9 here. This is 1 through 8. This is 1 through 8. Hmm. That doesn't help us much. This is 2 through 9. Okay. Okay, this sky paper's not helpful right now. Neither is this one. We've gotten all the zippers, the black crop keys, the thermometers, the indexes. German whispers. This is not there. These three, we don't know about that one. We have arrow, arrow, arrow. Zipper line, this zipper line. And then black crop key. So those are all the rule set we have. Huh. So the only way this is a region is if this is a region here. No, it could be here too. This could be valid also. I guess this is E technically, but we don't know where that is, right? Huh. Hmm. Okay, say this was 4. If this was 4, this is obviously 9. This is 9, which would force that to be 8, so this would be 3. That's fine. Can this ever be 9? And can this ever be 9 is kind of the question, right? So say this was a 9. That makes this, whoops. Say this was a 9. That makes this 8. Which means 3 is in the 8th column. 1, 2, 3, 4, 5, 6, 7, 8. So this would be 3. This would be 4, which would force that to be 9. So no, that cannot be 9 here. So none of these can be 9. So 9 in column, what is this? Sorry, row 8 can only be here, here, or here. So this could actually be 9 here. This is 9, this is 8, 7, this is 2. This would then have to be 2. That's interesting. That would be 1. Huh. So then this would be 5 to add up to 6, because that's the only one that could be there. So this would be 6. This would have to be 1 and 3. So no 3, 7, 8. No 3, 7, 8. 9 could not be, well, could be C, but it could not be D. This would then be 1, 2, 2, 4, or 3, 6. This would not be 1 or 2. This would be 3 or 4 here. This would have to be 6. So So there would be no 6 here. These couldn't be 6. This couldn't be 3. It's going to be 2, 3, or 6. So one of these would be 6. This couldn't be 9, obviously. This couldn't be 8. This would be 4, 5, 6, 9. But 6 could not be either of these. This would be 4, 5, 6, or 9 here. So this would be... Okay, 6 could not be here. Therefore, this would be 6 if this were 2. Therefore, none of these could be 6. This couldn't be 5 either. Therefore, this would have to be a 3, 6 pair. Which means this could not be 3 or 6. This couldn't be 3 or 6. This couldn't be 3. This would be 1. This would be 3. This wouldn't be 1 or 3. So it's 2 or 4 here, which eliminates 2 or 4 in the rest of the row. Or box. This can't be 5 or 6. So far, this is looking okay. This cannot be 3 anymore. Well, no, it could be 3 if this is 2 and that's 1. 7. This can't be 3 here. So 7 doesn't work because it would have to be 4 and 3 specifically. 8 could work. No. It would be 3 or 9. This would be 1 or 7. Right? If this is 3, this is 2, 1. If this is 9, this is 2, 7. So either way, this is 2. So this would be 2, this would be 4. This could not be 4 here. This could be 4 with 3 and 1. 5 with 3 and 2. 7 with 6 and 1. Or 3 and 4. This has to be the same as that. So it's 4, 5, or... Okay, this can't be 6. This can't be 6. D would have to be 6. Wait, but then you would have a contradiction. Okay. So, from this, we've shown 9 has to be, essentially... that was long convoluted. 9 cannot be this digit here. So 9 has to be one of these two. We know for certain. That was long. So this cannot be 9. Therefore, C and D cannot be 9 because we know one of these two is 9. So neither of these can be 9. 9 has to be one of these 4. 9 has to be one of these 4. This can no longer be 8. This can't be 8. This can't be 8. And this can't be 8. What if this were 8? If this were 8, this would have to be 9, which would force that to be 9. This would be 7. This would then be 2 and 2. This 9 would say 3 is in the 9th spot, so this is 3. So far, that's fine. This can't be 8. Neither of these can be 7, so this can't be 7. This can't be 8 here. So one of these two is an 8. This would not be, this could not be 7, and this could not be 7. This would not be 8. This would have to be 1. So again, it cannot be 1 and 7. This would be 5. This would be 6 and 6. So this would have to be 1 and 3. This could no longer be 3. This could no longer be 3. This couldn't be 3 either. This couldn't be 3. We have 4, 5, 6, 8. This can't be 6. This is 4 or 5. 2 would be in the 6 area. So this would be 6. No 5, 6, 7, 8. 6 could be here or it's here. So this is 1, 2, 3, 4, 6. This can never be 3. If this were 3, therefore that would be 6, and there would be a 1 to 2 ratio there. This can't be 6. This can't be 3. So it's 4, 5, or 8. This can't be 6. Where is the 6 then? 6 can't be here, can't be here. So this cannot be 8 here. Actually, can this... okay. This can never be 2. If this is 2, that forces 6 to be here, right? Well, 6 can't be here. 6 sees the D, so it cannot be there. It cannot be C because it sees the C also, and it cannot be there. Therefore, this can never be 2. Aha. And that's the key. I don't know where. Okay, so... this can never... I don't know why this is 6. This can never be 2. If this is 2, that becomes 6. 6 cannot be here. 6 cannot be either of these cells because they're next to 2, 3, and 4 at least on German whisper line. 6 can't be either of these because it sees C and it sees D. Therefore, these can't be 6, and these can't be 6 because it can't add up to 9 here because 9 cannot be here. Therefore, this is a 3. So it cannot be 7 here. This is 3. This must be an 8-9 pair here. This can't be 3. This can't be 3. This can't be 3. This can't be 3 either. So this cannot be 6 here. This 3 means this is a 6, so this is 6 also. This can't be 6. This is 8. This is 8, which forces this to be 9, which makes this 9, means this is 3 has to be in the 9th column. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 3. This cannot be 3 here. This can't be 9 anymore. This 8 means this can't be 8, so this is 9. This is 8 here. So this could still be any of these digits. This has to be 1, 4, and 5 here. Sorry, 1, 3, and 4 adding up to 8. This is 1, 7. It cannot be 2. And it's 3, or it's 3 and 5. So this is 5 or 7. This cannot be 8 here. This can't be 8 or 6. So this can't be 8 or 6. This is 3, 4, 5, or 7, which means this is less than 3, 4, 5, or 7. Same here. This has to be 1, 5, or it's 2, 4, adding up to 6. So 6 cannot be here. This can't be 6 either. One of these two is a 6. Because 6 can't be here, 6 can't be here, 6 can't be here. These can't be 6 either. This can't be 6, 8, or 9. This can't be 6, 8, or 9 then. This is either 1, 5, or 2, 4, adding up to 6. This can't be 6 here, so one of these 3 is a 6. This can't be 3 in either of these spots, so this can't be 3. Actually, this can't be 4 either. This is 5 or 7. So 6 is one of these 3 cells. This cannot be 3, because if that were 3... this is 2, 5, and 7 remaining. 2, 5, 7. We have a 2, 5, 7 triplet in row 9, which eliminates 2, 5, and 7 in the rest of the row. That leaves 1, 4, 1, 4, 1, 4, 8, and 9. Okay. If this is 5, 6 could be here. 2, 3, 4, 5, 7. So everything can only add up to 7 at most. So this cannot be 8 or 7 here. 6 has to be one of these two. This can no longer be 8. Hmm. This cannot be 4. These can't be 8. This has to be greater than 5. This can't be 4 either. This can't be 8. Remaining digits are 2, 5, 6, 7, and 9. 2 has to be one of these 3 digits. These must be in the same region, so this can never be 2. It was very unlikely for it to be 2 anyways, but 3, 4, 5, 7. The remaining digits in column 5 have to be 1, 2, 3, 4, 5, 7. This can't be 6. Where is the 6 then? It has to be here. So A has to be 1, 2, 3, or 4. So this is 3 or 4. Which means it adds up to at most it's 1, 2, or 3 here. Right? 8 cannot be 6 because this is 6, this is 6. That eliminates 6 here. 6 can't be here. 6 can't be either of these. So A is here and cannot be here, cannot be here. Eight has to be one of these 3 digits. We're not sure which. One, 2, or 3 is here, so this can never be 8 here. If it's 1, this is 2. If this is 2, this is 1 or 4. If this is 3, this is 6. So this can never be 3 either. This can't be 6, so this can't be 3. So we know there's a 2 in one of these 2 spots. I hope I'm doing this right. This can't be 3 here. The remaining digits here are 1, 2, 3, 1, 2, 4, 3, 4, 5, 7. 8 cannot be here. 8 cannot be here. So 8's either here or it's here. We're not sure which. This cannot be 6. If this were 6, this would have to be 3. So this can't be 6 either. So 6 is one of these 2 digits. This then is 1 through 6, 7, but it cannot be 3. If it's 3, therefore that would be 6 with the 6 there. So this can never be 6. This is 1, 2, 3. Oops. 1, 2, 3, 4, 5, 7. So A has to be one of these 3. A can be here or here. We don't know which. 6 has to be, okay, so 6 can be either here in the, not 9. 6 could be here, 6 could be here, 6 could be here. 6 could be here, or 6 could be here. Huh, interesting. Remaining digits here are 1, 2, 4, 5, 7. Okay. Okay. For zipper lines. This 3 means this can't be 3. That doesn't tell us very much. If this is 3, so that's interesting. If this is 3, this has to be 4, because it has to see all of these. This would then be 5. This would be 2 and 4, so this could not be 4. This would be 2. This would be 4. This would be 4, and this would be 4. That is possible. So then this would be a 1-2 pair. This could not be 2. So it would have to be 3 here, which would make this would be 1 then. So far this is all looking fine. This would be 1, this would be 2. So 2 cannot be here, 2 would have to be here, which meant this would not be 2, so this would be 2. This would be 1, so this would have to be a 3-6 pair then. This would be 6, this would be 3. This could not be 2, so this would be 7, this would be 2. So far it's looking fine. But 7 would be contradicted here. 7 could not be either of these spots, and it would have to be. So this cannot be 3 then. So again, that 3 forces this to be 4 to be seen. This has to be 5 to add up to 8. This must be a 4 because that's the only digit remaining, which forces that to be 4. This 5 means this has to be a 2-4 pair adding up to 6. So this is 2, this is 4. That makes this a 1, which makes that a 4. This 4 eliminates that from being a 4. This can't be 2. These two digits must add up to 4, so it can't be 2 and 2. It must be 1 and 3. So this is 3, this is 1, this is 2, so this can't be 2. This can't be 2, whereas a 2 in this box, it has to be here. This can't be, this has to be 1. 7 has to be this, but this can't be 7. Or 5, or 2. This 1 and 4 eliminates 2. and 1 or 2 and 4 as possibilities. So this must be 3 and 6. This can't be 2 because of that 2, so this must be 2. The 7 has to be here, but then the 7 also has to be here. So that's that is... So therefore this can't be 3. This has to be 1, which makes this a 7. So this can't be 7, this can't be 7. These cannot be 1 anymore. This is 7, so this can't be 7. Okay. Sees those fine. Oh boy. Hmm. Okay. Huh. Hmm. We have 2, 3, 4, 5, 7 left in column 5. But this can't be 2 because of the 2's here. And they're in the same region for certain. So 2's either here or 2's either here. I mean, that could certainly be the case. Hmm. This is interesting. So what happens if this is 2 and 2? So we try to make this 2 and 2. This is 4 and 4, obviously. Oh, that doesn't work. Right? If this is 2 and this is 2, these have to be separate regions. Ah, we know 3 has to be one of these 3 cells. Okay. That's interesting. Okay. So if we try to make this 2 and 2 adding up to 4, this has to be a separate region from this. Because this would be 2, that would be 2. But the problem is we know in this region it has a 2 here. So the only way this can be 2 is if this is part of this region, which would mean this is 2 and 1, and this is 3. And this would then be 3. Interesting. The other part of this region would then have to be 1, right? So either 1 is here or 1 is here. So if this is 3, this has to be 1 and 2. If this is the same region, then this would be 4, this would be 2, this would be 1. If this is a different region, okay, so how would that work? If these are different regions, if it's here and here, this could not be 2 because of the 2 having to be one of these 3 cells. So then this, okay. So if this is ever 4, it's 1 and 3 here. And that's pretty straightforward. Right? So if this is 4, this is 1, which makes that 2, which makes that 3. Therefore, this would be 4. This would, one of these would be 4. This would be a 2-4 pair here. Which would mean 2 would have to be here. This would have to be a separate region. This would then have to be a separate region if that's the case. Because you cannot have 3 essentially being here in this region. Because 3 has to be one of these 3. 3 cannot be here, 3 cannot be here because of that 3 and that 3. And these digits are already set. So if this is 4, this is 1, okay, so if this is 4, this is 1, 3, this is 4. This would be a 2-4 pair here, which eliminates 2 and 4 here. So this would have to be 1 and 5. So no 1, 5 here. This would be 2 here. Therefore, this would be 3, which means this could not be 3, 6. So this would be 6. You'd have 1, 5, 1, 5 here. This could not be 1. This could not be 1. This can't be 4. This can't be... You'd have 8 or 9 here. 4, 8, and 9 here. This can't be 2. Therefore, this would be 2. So 2 would have to be one of these. It would be with 1 or 4. Therefore, this would be 5. This would be 1. This one says that. So this has to be 4 here. So far, this is okay. 1 has to be one of these 2. Therefore, this would be 4. This 1 would make this a 4, which would make that a 1. This would be a 2-4 pair. That's okay so far. This can't be 4 or 2. So this must be a 2 here, which makes this a 5-7 pair here. This can't be 4 or 2. One of these is 3, and we have a contradiction because 3 would be here, and that would be next to 3, 5, 7. And one of these would have to be 3. So it cannot add up to 4, we now know. So this must be a 3. This must be 3, and this must be 1 and 2 adding up to that. So this is 3. This cannot be 3. This cannot be 3. This can't be 6. So this can never be, well, it's going to, 1, 2, 3, this can never be 5 here. To index that. We have 3 here, 3 here. This cannot be 3. So one of these 2 is a 3. This cannot be A. Because you can't... have 3 adding up with 3. This can't be A, therefore this is a 3 here. So this can't be 3. Where this can't be 3, where is the 3 in row 8? It has to be here. So this is 3, this is 6. This cannot be 6 anymore. This then must be 5 or 7, so this is 2 or 4 here, adding up to 5 or 7. This is 3, because there's no other place for it. 3 has to be one of these two. So we can remove the A's, instead replace them with 3's. We don't know if this is the same region. This is 1, 2, 4, 5, 8, 9. Cannot be 9. So 9 in this box has to be one of these two cells, which means this cannot be 9. So 9 has to be one of these two cells. This cannot be 6. So therefore, this can never be 9. Because this 6 would reference that as a 9. So that can't be 9. So 6 is either in 2, 6, or 7. 9 can still be 2, 4, 7, 8, 9. Any of those spots. 8 is here. 8 is here. This cannot be a region, because if this were a region, it would require an 8 here, and 8 cannot be here. Actually, we should have figured that out to start with. So this can never be a region. Therefore, this is the start of a region. So it has to go this way. Since it must go this way, it must include at least this one. So this is part of a region. So we know this is a region, this is a region here, and this is a region. Okay, so we can remove these blues. This is a region. These are a region. This is not part of a region. 8 has to be one of these two digits, which means 8 cannot be here. One has to be one of these digits, so neither of these can be 1. So since this can't be 1 here, this cannot be 5 to add up to 6 here. So one of these is 1, 8 is one of these, 2. This can't be 2 because of this 2, so this must be 1, which makes this a 2, so this can't be 2. This is 1 or 4 here. This is 1, so this can't be 1. This can't be 1. So one of these two is a region. Goes to here. So this cannot be part of a region. So this is not A anymore, it's 3. And these cannot be part of a region. So this is 3, which means this can never be a 3, so 3 has to be one of these 3 digits. This is 1 and 3. 2 is in 1-2 ratio with 1 and 4. If this is 2, this becomes 4. This is 1. So if this is 2, this is 4, this is 1, which forces this to be 4. And therefore, this cannot be 4 here. And this would be 2 and 4 adding up to 6. So therefore, we would have contradictions. So this cannot be 2 here. If this is 4, this would add up with 2. This would become 2, so this would be 5, and this would be 5. That seems fine. So this is 1 or 2 here. It cannot be D here. So D is one of these two. We're not sure which. If this is 5, this becomes 5. That's a 5. So this becomes 2 and 4. Ah, this cannot... Well, we already knew that. Ah, this 2 means this can't be 2. So this must be 1. This is 5. Which makes this 7. So this can't be 1 or 5. This 1 eliminates that 1. So this is 4, which makes that a 2. This can't be 1. This can't be 1, 2, or 5. This has to be a 5 here. This is a 7, so this is 4, which means this is 1. This can't be 4. This is 8. This can't be 8. These can't be 4. This is a 2, 9 pair here. This can't be 7. This can't be 7 anymore, so 9 cannot be here. This cannot be 4 because of this 4. Remaining digits here are 1, 2, 4. This can't be 2. It's 1, 4, 5, and 7, right? But this can't be 1 because of this 1. So we have a 4, 5, 7 triplet in column 3, which eliminates 4, 5, and 7 from the rest of the column. Therefore, this is 1. So we have 2 and 1. These two digits must add up to here. This can no longer be 2, because if it's this 2, this has to be 1 and 1. So this is 4, 8, or 9. If this is 4, this has to be a 9. If this is 8 or 9, it cannot be 1 or 2 because of the 1 or 2 here. This has to be 3 or 4. That's interesting. Okay, this can't be 4, though, because of this 4. So this is 3 or 9 here. If this is 9, it could be with 1, 2, 3, or 4 here. If this is 3, it has to be with 9. So either way, this is 9. Right? If this is 9, obviously it's 9. If this is 3, it can't be with 8 anymore on the German whisper line. It has to be 9. So this cannot be 9 here, which means this can't be 7. 9 has to be one of these two, because 9 cannot be here. So 9 cannot be here. Therefore, this can't... Okay, so this can't be 9 here. This can't be 9 here. So one of these is 9. This is an 8 or a 9, which forces this to be 3, which forces this to be 9. Interesting. These can no longer be 3. Where is the 3 allowed to be? It has to be here. So this must be the region then. Oops. Therefore, we know this is the final part of the region. This is dark. This is 8 or 9, so these two add up to 8 or 9. So this is 1 through 7. Or 1 through 8. This is 1 through 8. But you cannot have a 3 either. 1 or 3 here. No 3 here. So this can never be 8 here. So this can't be an 8 here. This is 8 or 9. This is... So 3 is here. Remaining digits in column 4 are... Can't be 1, cannot be 2, can't be 3, could be 4, no 5, 6, 7, 8, or 9. So this is 4, 8, 9. We have a 4, 8, 9 triplet in 6 has to be one of these 3 digits because 6 cannot be here and 6 cannot be here. Therefore, this can't be 6. This is 7. This is 5. This can't be 5. This is 1, 2, 4 here. This can't be 2 or 7 here. This can't be 1. This can't be 5 because of that 5. This can't be 5. This 4, 8, and 9 triplet in column 4 eliminates 4, 8, and 9 in the rest of the column. Therefore, this is a 2, 3 pair. This cannot be 2 because of the 2, 3 pair in the box. This can't be 5 because of this 5. We have 1, 2, 4, and 6 here remaining in this box. Then we have a lot of stuff remaining here. This is 4, 5, and 6. The only ones that can add up to 8 or 9 with 4, 5, and 6 are 2 and 4. The 2 could add up with the 6 to the 8. The 4 could add up with the 4 or the 5 to the 8 or 9. So this is 2 or 4. But this 4 means this can't be 4, so this is 2. So this has to be 8 here, which means 9 is in the 8th spot, 8th column. So this is 9. Therefore, that makes this a 4. This is 8. This is 9. These can't be 4 here. Actually, we kind of already knew that. This can't be 5, 7. This can't be 7. It's a 2, 6, 9 triplet here. This can't be 2 because of this 2. This can't be 2 or 8. This has to be 2 and 6 adding up to 8 here. So this can't be 6. These add up with these digits to add up to 8. It could be 1 or 2 or 4 to add up with 4, 6, and 7. This can't be 7, so this can't be 1. This can't be 6, 1, 2, so this is 4, which makes this 2. This is 1. This has to be 6. This 1 eliminates that 1, so this is 8. This is 1. This 2 eliminates that 2, so this is 5. This is 2. This 5, 7 pair eliminates this 5, 7 pair in the column, so this is 4. This has to be 5 and 7 here. This 4 eliminates that 4, so this is 7, which makes this a 5. Therefore, this is 4. Therefore, this is 6, which makes this a 2. This 2 eliminates that 2, so this is 3, which makes that a 2. This 9 eliminates that 9, so this is a 4. 6 cannot be here anymore. It could be in 2 and 6. Remaining digits here are 1 and 4, I believe. This 2 eliminates that 2, so this is 9. This is 2. We have 1 and 4 remaining in row 4. We have 8 and 9 remaining in this box here. Therefore, that leaves this as a 5. This has to be a 1, because that's the only digit remaining in the column. This has to be a 7, because that's the only digit remaining. This has to be 4, 9, but this can't be 4 here, so this must be 9. That can't be 4, 9. This 8 makes this a 9, which makes this an 8. I don't even know where I came up with that. This is 4 and 5. This can't be 4 because of that 4, so this is 5, which makes that a 4. This 6 makes this a 9, so this can't be 9 here. This 7 eliminates that 7, so this is 5, which makes that a 7. We have, in row 3, 2, 6, and 5 remaining. Ooh, but we have a contradiction because this can't be 5. Oh, no! No! Ugh. Where did I go wrong here? Where did I go wrong? This is tough. I'm so close. No. No. This would have to be 7, 8. Okay. Frig. I don't know where I made the error. I don't know. This is even for a deconstruction one, this is a very tough one. So this is not easy, and if I guess I made a mistake, and I don't know where I made the mistake. This is tough. Wow. Shoot. Man. Really? Really? Just that one small part, too. It's not even like it's everything else seems to work. It's just that one there. It's just, oh man. And I bet it's a small error too. Or it's a not small error, but it's like the one issue. And I don't know where the heck it would be. Okay, we've already spent 3 hours on this. Wow. We were so close too. Actually, were we? I don't even know. Maybe we were. Who knows? I think we were actually really close. But the problem is that it did not run in it. Oh boy. Yeah, I mean, aside from this having to be a 5, everything works, right? 3 adds up to 3, 1 and 2 adds up to 3, 1 and 2 is in a 1 to 2 ratio, 6 and 2 add up to 8, 2 and 6 add up to 8, 8 is 5 away from 3, which is 5 away from 9, 1, 2, 5, 7 increases, 8 adds up to 8, 1 and 7 add up to 8, 1, 3, 4 adds up to 8, 3 is 5 away from 9, which is 5 away from 2, which is 5 away from 9, which is 5 away from 3, which is 5 away from 8, which is 5 away from 3. 3 and 7, 4 add up to 7, 7 adds up to 7, 6 adds up to 6, 1 and 5 add up to 6. This sees 1, 2, and 5. This would see 6, 7, and 9. This would see 7, 8, and 9. But the problem is we have a 5 here. 5 has to be here because you can't have repeats. And then that's a contradiction. So everything else works. I don't know if I can find it right now. It's been already been 3 hours. And but I can go back to this and it shouldn't be as bad. But we have to go through the logic again. Oh, we can't reset it either. We just have to make sure our logic is clean. This actually, oh man, everything works except for this 5. Oh man. This would be 1, this would be 4, this would be 7, this would be 5. Yeah, everything works. This would be 7, 8, and then we have 2, 5, and 6 as a problem here. And that's the issue. Because 5 cannot be here. 8. Wait. Hold up, this is not index. Ah, that's the thing. Okay. Maybe this can solve it. This is not an index. I don't know where I got the idea that was an index. Okay. So, we have to, okay. Yeah, this isn't an index. I don't know where I got the idea that's an index. So that might be the error that we were running into. Okay, let's go back. Okay, so why do we have this 9 as an index? Whatever. Okay, so no. What can this be, essentially, is the question, right? This 3 means this can't be 3. This 3 means this can't be 3, so 3 has to be either here or here. This... What do we know of this? This could... Okay, so this could be 2, 4... It's on a German whisper line. It cannot be 5. It can't be 6 or 7. It can't be 8. It has to be 2, 4, 8, or 9, right? And if this is 2, this would have to be 1 and 1. So this cannot be 2. So we know it's 4, 8, and 9. Okay, so that's good. 4, 8, 9. 6 can still be here. Okay. Yeah. Maybe we saved it because this is not an index. That's where we messed up. If it's 4, it could be 2 and 2 here. That could be fine. One of these is 8. Yes, what are the possibilities for these cells in column 4? No 1, no 2, no 3. This cannot be 6, so one of these is a 6, which means these can't be 6. If this is 4, this is 9. If this is 8 or 9, this cannot be, this has to be 3 or 4, but it can't be 4. So either way, if this is 3, this has to be a 9 here. Because it cannot be 8. If this is 9, obviously it can't be 9. So this cannot be 9. This has to be less than that. 6 has to be one of these 3, which means this can't be 6. Because 6 cannot be here, 6 cannot be here. 6 has to be one of these 3, which means this can't be 6. This is 7. This is 5, which makes this 1, 2, and 4. This can't be 5 or 7 here. This is a 2, 6, 9 triplet here, which leaves this as 8. So one of these is an 8. So we have an 8, a 4, a 5, or a 7. But it cannot be 5 or 7 here. This is 4 and 8. So this 4-8 pair eliminates 4 and 8 from the rest of the box. This is a 5-7 pair, which eliminates 5 and 7 from the rest of the column. So this is 2, this is 5. This can't be 2, 5, or 7, so this is 4. These can't be 4. This 4, 8 pair eliminates 4 from being here, so this is 9, this is 4. These can't be 4. So we have a 5, 7 pair, which eliminates 5 and 7 from the rest of the column, so this is 4. This 2 or 6 says that 6 has to be one of these two digits, so this cannot be 6. This is 2, 6, 9. One of these is 9 here. This 4 eliminates this 4, so this becomes 2. This is 1. This cannot be 1 or 2. This is a 3, 9 pair then, which forces this to be 4 and 6. This can't be 4 because of that 4, so this is 6, which makes that a 4. This 5 eliminates that 5, so this is 7. This is 5. This cannot be 1, 2, or 4, so it's a 5, 7 pair here. Okay, this 1 eliminates that 1, so this is 8, which makes this a 1. This is 4, 8, and 9. What are the remaining digits here in column 8? They have to be 2, 3, 7, or 9. Well, this can't be 3 here. This can't be 9 because this is the same region as this. So this is 2 or 7. This is... Okay, what are the remaining digits here? It cannot be... This is 2 or 7. So this can never be 4. If this were 4, it can only be 2 and 2 added together, but this can't be 2 here. So this is 8 or 9 here. So that's still the same. This is 2, 7, or 9. It cannot be 5. 5 cannot be either of these. Ooh. This is 8 or 9. It has to be with 3, which makes this a 9. This is 2, 7, and 9 here. Therefore, this can't be 3. 3 cannot be here. 3 cannot be here. In this region, then, we have to have a 3. 3 can't be here. So this is not a region. But we still have problems. Yeah, this is the region, so we still have this as a region. Crap. The remaining digits in row 4 are what? 5, 6, 8, and 9. But 5 cannot be any of these digits, so it's a 6, 8, 9 triplet, which forces this to be 5. 5 cannot be here. 5 cannot be... 5 can't be here. What digits are these? This is... 1, 3, and 6 remaining. This can't be 3 here, so this must be a 3. This can't be 1, so this is 6, which makes that a 1. So this is 2 or 3. This cannot be a 3 here, so this must be 2, which makes this an 8. That makes this 4, which makes that an 8. 5 cannot be here. 5 can't be here. So where's the 5? It has to be here. So this is 5. This is 7. This can't be 7. This has to be 6 and 2, which makes this 9. Therefore, this is 7. This is 9. This cannot be 9 here. This is 4 and 5, which makes this a 5 and this a 4. This 2 means this can't be 2, so this is 9. This is 2. This can't be 6 or 8, so this is 9. This can't be 6 or 9, so this is 8. This can't be 4. This 2 eliminates this 2, so this is 3. This is 2. We have 1, 4 remaining. This can't be 4 because of that 4. So this is 1. This is 4. This is 2, 6, and 9 remaining. Ah, yes. So the 9... Yeah, this is not an index. Okay, so good. Okay. This is 7 and 8. It sees 3 digits. Therefore, this is 7. This is 8. This is 2, 6, or 9. But 6 cannot be here. This can't be 2 either of these places. So this must be 9, and this is 6, which makes this 2. This is 6. This has to be 7 to see 3 digits. And this is 5. We solved something! Congratulations! Oh, we don't have this one yet. Congratulations! Okay, we have... Wait, did we already have that before? I guess we did. Yeah, we did have that. And I found another hidden puzzle. So this has to be 9 here. Oh my god, that was crazy. Hidden puzzle designated by Dancer. What's Dancer? Designated by Spider. In this 4x4 grid, enter the digits from 1 through 4 into each row, column, and 2x2 box. So these are the digits 1 through 4. This has to be greater than 1. So this is 2 or 3. This is greater than this digit. So this is 3 or 4. You're continuously increasing, so this is 1 at minimum, 2 at minimum, 3 at minimum, 3 or 4. This is maximum 4, maximum 3, maximum 2. This is 2 or 3. This has to be 2, because it's greater than 1. So this is 2, 3, and 4, which makes this a 1. That makes this has to be 3. This is 4. This has to be 2. This can't be 3, so this is 2. This is 1. This is 4. This has to be increasing from here. This has to be 3 because it has to be increasing there. This is 1. This must be 4. This is 3. This must be 2, and this is a 1. And did we solve it? We solved the spider. So then we have outside the boxes quest given by Sudoku Guru. You have learned much, but you are still bound by the confines of the grid. Only by letting your mind free, remember all clues. Cells outside the grid may contain 0. What is this? Solve the title. Oh, we have to solve the title here. Wait, but what does that mean? Oh, interesting. This is a 1-to-2 ratio. Wait, but what does that mean? How do we solve the title? Wait, why do we have random digits here? I don't get what the random digits are. Oh, we have a hidden puzzle here. We have another hidden puzzle. Wow. Okay, so that's another hidden puzzle here. This is designed by Dancer. In this 4x4 grid, enter digits from 1 through 4 into each row, column, and 2x2 box. Okay, so this is 3 digits. This is a 5. Oh, this has to be 0, doesn't it? So this is 0. This then is 6 through 9. Okay, so that works. So that found Dancer. Wait, why did it say I solved Dancer? I haven't solved Dancer yet. We did Serpent and Wolf. Why does it say I solved Dancer? Why does it say that? Okay, go back here. Okay. So why does it... It says I solved spider, but I haven't... Oh, no? Oh, I have to have... Oh, wait. This is 0. So that would be solving spider? Let's zoom in. Zoom out here. Right. Yep, that solves spider. Okay. Dancer, I don't know why it says I solved it. I didn't solve it yet. We have to go up here. Nope. We want to go over here. Yep. And then go over here. So we have this hidden puzzle. And we have to solve the title. I don't get what that means. We have random digits here, too. We have a 0 here, a 3 here, a 7 here, a 2 here, a 9 here. Why is it just randomly there? So this is a palindrome line. This is a 1 to 2 ratio, but there's nothing there. This is an arrow. Maybe I have to solve this? Okay, so this is 1, 2, 3, 4. So this is... Okay. This is at least 7, right? Because it's 1, 2, 3, and 1 at minimum. This... Okay, So this has to be 7, 8, or 9. If this were 7... This would be 1, 2, 4. This would have to be 1, 2, okay. Okay, these two digits must equal these two digits. Whatever these two digits are cannot be these two digits, and they have to equal this two digits. Therefore, these two digits are equal to these. Oh, that... So this can never be 7. This could be a 1 here. So this is 8 or 9. Either way, this must be essentially 4. Because these two digits must equal the same as these two digits. Right? And the only way those two digits can actually equal... Oh, this could be 1 and 2 also. So this could actually be 7 here. Oops. I don't know what I did. This, though, has to be 1. This has to be 1, and it's 1, 2, or it's 1, 3. But these digits are the same as these. This, then, is 2, 3, 4. This is 2, 3, 4 here. This can never be 4, though. So where is the 4 in this box? It has to be here. Right? If this is 4, this cannot be add up to 9. At most. It has to add up to 10. So this is 4. This is at least 2. So this is 2, 4. This is at least 1, 2, or 3. So this cannot be 4 here. Which means 4 has to be here. So this is 4. One of these two is a 4. We have 1, 2, 3 here. One of these must be a 4. So since one of these is a 4, that's 1, 2, 4 at least, which is 7. So this has to be 2. So this is 2, this is a 9. This can't be 2. This is 1, 3. 1, 3. This must be a 1. This has to be 2 and 4. Which makes this not 2. So it's 1 and 4. Okay, so this is 2 with 1, 2, and 4. So this is 1, 2, and 4. This can't be 4, though. This can't be 1, so this is 3. This is 2. This is 4. This 3 means this has to be 1. This is 3. This is a 1, 2 pair. This has to be 2, 3, and 4 adding up to 9. This can't be 3, so this must be 2, which makes this a 3. This is 1. These can't be 1 or 2, so this is 4. This must be 2. This must be 1. This is not 3. This is 1, and this is 3. So this should be solved then. How do we solve the title? Okay, so we finally solved dancer. What are these? I don't get what this is. How do we solve the title? Oh, right, we don't need to click. We just need to go to the area, then zoom out, then zoom in. Maybe I can click on the title? No. Designated by Hall of Illusions. I don't get this. We have ATE, doesn't do anything. How do we solve the title? This has to have a 1 to 2 ratio. But I don't see any other digits. Hmm. Hmm. Do we have letters? I don't know. R I A E S E. So there's that. I don't know what U's in a 1 to 2 ratio with. What is U in a 1 to 2 ratio? W? Okay, so this is W. 8. Ah, this is 8. There we go! Okay. Thinking outside the box, I guess. The castle of Sudokuvania shimmers in the morning air and dissipates with the last of the remaining fog. A short distance away, you trudge up a small hill towards the waiting figure of the guru. Somehow, you aren't surprised to see her here. The world will never know how you saved Sudoku from this cultist, she says. Was it worth it? Did you find what you were looking for? You think about the adventures you've had and the friends you made along the way. What friends do we have? We had the guru and the snake. I guess we tackled some people. No, I guess those were the only friends. And you nod. You may not have found the secret of Sudoku, but you did gain insight you'll keep all your life. That and a sack of gold. One more thing, the guru calls as you depart. You wish you would stop doing that. Did you remember to turn off the lights before you left? Oh, bobbins. Oh, man. Wow, that was... That was a journey, definitely. Definitely a journey. That was... Wow. Especially with the deconstruction puzzle at the end, that was really difficult for a deconstruction puzzle. I actually have not done very many deconstruction puzzles, but Oh man, that was pretty hairy. Just the logic you had to come up with that. Whew. Yeah, and the coins, you had to fill out these to get the coins. That would have been nice to know that that was specifically used for that purposes. Maybe I should have thought of that though, but it never entered my mind really. Wow. Just wow. That was definitely a journey. Um Thank you, Skeptical Mario. That was though frustrating and very time consuming, that was still kind of that was still no it was quite fun. Like it was definitely quite fun, but aggravating at times, particularly when I made a mistake and trying to figure out where my errors were. I almost gave up on this deconstruction puzzle to like restart sometime later, but then I realized that I had messed that part up. This was not an index essentially. And then I was stuck with, wait, what is this? How do you solve the title? And then it's like, it has to be letters. This is U, this is double U. This is 8, therefore this is 8. Clever, very clever. Anyways, I hope you enjoyed this journey on this trek through Sudokuvania. And I hope you had a good time watching this if you just watched it. If you solved it, good for you. This was tough. This was really tough. But that's because, like, yeah, there were 10 grids, there are 4 secret grids, there were 2 joining grids, and for each of the 10 grids, you had a boss on it except for the last one. And the last one was a pain to actually figure out. Wow. Just wow. That was definitely a journey. I hope you enjoyed either watching me solve this throughout all the videos I did, or even solving it yourself, if you solved it yourself. If you did, bravo. Good job. This was not easy at all. So that's essentially 19 solves, 19 grids of Sudoku that you solved, plus two mini ones, plus 4 hidden rules, plus the letters that you had to think of, and you had to think outside the box there, plus the outside hidden ones, plus these other quests that you had to solve. Wow. If you stuck through it, good job. Good job. I'm patting myself on the back for that too, because that was intense. That was intense. That was I don't even know how many videos. Let me check actually. I can tell right now. That was 10 videos worth. 10 videos worth of solving, each about 2 or more hours. I mean, which is about right, right? Because particularly since these were most of these grids were not easy to solve, right? And I kept you're gonna make mistakes sometimes. So the problem is basically figuring out where you made the mistake and going back and solving it. And the problem is that these grids essentially need to make sure that you're not incorrectly solving them, because that will affect solving future grids. So, wow. Anyways, I hope you enjoyed whatever part of the puzzle you solved or whatever part of the puzzle you watched me solve. And I'll see you next time on Frank Puzzles. Take care.